Alright, hello everyone, this is Mr. Crozier. I'm going to go over the practice test with you. Problem number 1 says we have a function and it's vertically dilated by a factor of 3. So that means we take the f of x and we multiply that entire function by 3. So in this case we have 3 times the entire function to get the result. On problem number 2, again we have a function and we're going to have 3 different changes to it, and if you read this paragraph it tells you how to change it, and it tells you that a horizontal dilation by a factor of 3, well that's affecting the inputs, so it's 1/3 here. Vertical dilation by a factor of 2, well that's the same thing we had up here, 3 times f of x, so I'm going to times it by 2 in this case right there, and then we're going to translate up 8 units. It's positive, so we add it on. So now we have 2 times f of 1/3 x. If we put the 18 in there, 1/3 of 18 is -6. Now we can use the table to figure out that f of -6 is 12. Then we can finish the math. On this problem, you can see the different functions, transformations. We have a vertical dilation by half, reflection over the x-axis, translation 1. On number 4. We have a function here, same thing, we're going to have the 3 different parts, vertical, times it by half, and add 5, and a movement left. So all of these different translations are up here, or transformations are up here, and they'll tell you how to write the equation. Alright, let's continue. Number 5, we have a function here, and it's simply down by 10. So I take a function, I subtract 10. So there's my function, I subtract 10. On number 6, we have a graph, and there's 2 transformations in here. Right 2, down 5. So every point has been moved right 2 and down 5. So you can just line it up, 2 and 5, 2 and 5, move everything down. You have the same picture, shift it over. Alright, on the back, we have our first composite function. I take the f function, put the g function in there, simplify the work. Number 8 is just a backwards version of this. They want to know what the 2 parts are. And the first part is f of x is this function, and the g of x is that function. So this g function is inside there. We have an inner function and the outer function. On number 9, we are, same thing. We have a function. We're going to put the g function in there, but the key is what's the domain in here. And remember, you can't have negative numbers, so you can't take the square root of a negative number. So this cannot be a negative number. So it's all real numbers such that x is greater than or equal to 0, because you cannot have negative numbers. Now, there's no way to get a 0 in the denominator, so the only restriction we have is that x has to be greater than 0. On number 10, you find the f function, which is 3. F of 3 is 1, and then you take your 1, put it into the g function. On number 11, you take the f function here, put the g function inside of it, and then you FOIL this, distribute this all the way, and then once you get to right here, you can still go x squared divided by x squared is 1. This divided by this divided by this, minus 3. And then you can simplify it down that way. So once you're here, you still have a little bit of algebra to do. On number 12, we do g of 0, which is 1/2. Now we have 9 to the 1/2, x to the 1/2, or 1/2 to the 1/2 squared, sorry. 9 to the 1/2. This means the second root of 9 to the first power. 9 to the first power is 9. The second root of that is 3. Add the fractions we have here. A little bit of composite functions. Do 2 tables. First do g of -2, which puts you at 2. And now do f of 2, which puts you back to 0. 14, you are just checking the differences. First differences, second differences. Second differences are the same. It's quadratic. On the next one, same thing. Here's my list of numbers. first differences are not constant, it's not linear. The second differences are, it's quadratic. Function here, switch the x and the y's, and now solve for y. There's your inverse function. The dog groomer is a piecewise function. We have three different price structures. For dogs less than 15, it's 35. For dogs from 15 to 40, it's 40. Dogs over 40, it's $50 plus anything over 40. So every pound over 40, they pay $2. What's the graph look like? Well, it's a piecewise function. We have a horizontal line, and then we have another horizontal line, and then we have a diagonal line. Now to figure out this diagonal line, I calculated this point so I could get that point in the right spot, and I know it started at 50. So we have horizontal line, diagonal line, horizontal line, diagonal line. On problem 18, this is a graph of the function. If I were to graph its inverse, well, that simply means I change the x's and y's around. So right now, this point right here is the highest point on the graph, 7, 5. But if I switch this around, it becomes 5, 7. So now the highest point is going to be up there because I switched the x and the y. So this is my new maximum. It used to be 7, 5. 5 was the highest. Remember, when you were looking for a maximum value, you're looking for a y value. So 7, 5 becomes 5, 7, and now this becomes the new highest point. We have a function here, and the easy part is to find its inverse. We take this, switch them around, do the math, and now I have a function. However, we need to think of the domain. And the domain on this one's going to be a little tricky because you have to go back to the original equation. The original equation right here, this x plus 5 has to be greater than or equal to 0. So the domain of the original problem is -5 or more. So -5, -4, -3, -2, -1, 0. And the outputs there would be 0, 1, √2, √3, √4, which is 2, √5. So now when I switch them, this domain becomes this range, and this range is now my new domain. And if you look at this, these are all positive numbers. So you can only put positive numbers into this inverse because the range is here. All right, on the back, number 20, simple problem. If we have a table of functions, if we do the inverse, we just flip-flop them. Just make sure you get them lined up correctly. This is 5, -4. It's -4, 5. This is 2, 3. This is 3, 2. Another problem on 21. Same type of problem. Inverse is easy to find, but the range is a little tricky. Look at this domain for the function. -3, -2, -1, 0. That's this domain. So if I flip it around, now this domain goes over here, and this is now the new domain of this function. So the outputs here are now the inputs. So those go down here for the range. It's only graphs from there. 22, we have a graph of a function. We take all of these points and we flip the x's and y's. And the graph is reflected over this axis. 0, 0 stays, 1, 1 stays, but this point right here, the coordinates of this point are 1.53. So the inverse is 3, 1.5. So now it's going this way. It's going up this way. And when you go ahead and you do the inverse function, I'll draw it in red, looks like this. It looks like the same graph that's been reflected over this line. Function right here. Again, what we're going to see is if this is my function, 2x squared minus 1, this is my domain, 0, 1, 2, 3, 4. This is my range, these numbers. Well, this now becomes my new domain. This range becomes the new domain. x has to be greater than -1. Linear function 24. Linear function, find the slope. Here we go. Find the b value. Now we can use the equation to find x when f of x is 200. So they're telling me y. I go back and figure out x. On the last problem, I have an inversely proportional problem. There's the start. Figure out the k value, and now I have an equation that I can use. And they tell me what's the demand. If the price is 20, I put a 20 there and do the math. All right, hope this helps with your practice test.